Hi, welcome to CoreJava tutorial. So today in this class we are going to discuss the concept called polymorphism. Okay, so polymorphism in the sense many forms. Okay, so polymorphism in the sense it is the concept of defining multiple functionalities with the same name within the same class associated with the same object is known as polymorphism. So if you come to the point of types of polymorphism, there are two types of polymorphisms available. So one is compilation time polymorphism and runtime polymorphism. Okay, so polymorphism in the sense it is the concept of defining multiple functionalities with the same name within the same class is known as polymorphism, and there are two types of polymorphism. The first one is compile time polymorphism and second one is runtime polymorphism. So if you come to the point of compile time polymorphism, so out of multiple functionalities defined within the same with the same name within the same class, so which functionality to be executed, that would be decided at the time of compilation of the program itself. So that is known as compile time polymorphism. So out of multiple functionalities, if the decision making happens at the time of at the time of running the program, that means out of multiple functionalities defined within the same class, which functionality to be executed, if that would be decided at the time of running the program, then that would comes under runtime polymorphism. So runtime polymorphism can be explained in the concept of inheritance. Okay, so I will explain you the concept of the runtime polymorphism or dynamic polymorphism whenever I explain the concept called inheritance. Okay, so here let us see the compile time polymorphism. Okay, so let me take before that let us go through the definitions once. Okay, so polymorphism in the sense it is the concept of defining multiple functionalities within the same class is known as polymorphism. So out of multiple functionalities defined within the same class, so which functionality to be executed at the time of compile, that would be decided at the time of compiling the program itself. So that is the reason we call it as compile time polymorphism. Okay, so let me create a class called class poly. So the name of the class is poly1. So inside this class what I will do is I will create a function called void function 1, so which is going to accept 0 arguments. Okay, so here inside this particular function I will write one statement, system dot out dot println. So here this is function 1, so which is going to accept 0 arguments. Okay, so I'm going to create one more function with the same name. Okay, so function 1, so which is going to this is function 1, so which is going to accept integer as an argument, so int x. So here what I will do is I will mention int x. So here this is the function which is going to accept integer as an argument. I will create one more function with the same name but with different arguments. So here it is float. Okay, float x. I will create one more function. Okay, I will create one more function with the same name which is going to accept two integers as an argument. Okay, int y. So if you observe this class, so I have defined a function called function 1, so which is going to accept 0 arguments, and I have defined the same function which is going to accept integer as an argument. I took the same function. Here there are two arguments, here one argument which is of type float. That means I have defined 4 functions over here with the same name but with different arguments. Okay, so now let me save the program with the name poly1. Okay, poly1.java. So let me save the program, and if you want to compile the program, obviously we have to go to the command prompt. Yes, and here use the javac command, javac space poly1.java. So see here there is no compilation error. So now if you want to run the program, so let me have one main function here, public static, okay, static void main. Here inside this I am going to write string args. Okay, so here inside this main function I will create an object of this class. So because why I am creating an object of this class, in order to load all these non-static members to the RAM, obviously we need to create an object of a class. So poly1 p1 equals to new poly1. Okay, so I have created an object of this class. So whenever this object of a class has been created, then what will happen? So it will allocate some memory space in the RAM, then it will load all non-static members to the RAM. So what are all the non-static members are available? So there are 4 non-static members are available. That is void function1, which is going to accept 0 arguments as a 0 arguments, and void function1, which is going to accept integer as an argument. The same function1, which is going to accept in 2 integers as an arguments. Okay, so I create one more function which is going to accept float as an argument, right? So float, it is some x or y, whatever it is. Okay, so here there are 4 functions defined inside this particular class. Whenever you instantiate this class, obviously it will load all non-static members to the RAM, and finally the address of the object will be saved into the reference called p1. Okay, and this object will be referred with the help of the reference variable p1. Okay, so the next one is, if you want to access this particular non-static variables, then obviously you have to use the reference variable name followed by the dot operator and followed by the name of the member which you want to access, right? So here if you observe this, there are 4 functions with the same name but with different type arguments. So now if I want to call the function1, which is going to accept 0 arguments, then obviously I will call like this, function1. So I won't pass anything, so the control will come here and it will execute this particular line. The next one, see, now save the program and come here and compile the program. Java C space poly.java. Okay, so there is no compilation error. So now Java space poly. So I am trying to execute this program. See, this is function1. So whenever the control comes here, it will identify the function1 which is going to accept 0 arguments, and the control jump from here to here, and it has executed this statement. So once this entire particular function has been executed, then the control return back to the calling place of this function. That means the control back to this particular function, because this is what the calling place of this particular function, and it will proceed to execute the statements further. Since there is no statement available, the termination of the program takes place over here. Okay, so the next one is, I am going to call, so if you want to call the function1, so which is going to accept integer as an argument, obviously we need to pass some integer value, right? So that means p1 dot function1, so here I will pass some integer 23. So let me save the program and come here and compile the program. So to compile this, Java C, compile this and execute the program. See, so it has executed function1 which is going to accept integer as an argument. So now at the same time, if you want to call one more function, that means function1 which is going to accept 2 integers as an argument, here we need to pass 2 integers like this. Okay, save the program, and again if you want to call the float, then obviously p1 dot function1 which is going to accept float. That means here we need to pass the float value, right? So if you want to pass the float value, here dot 3 or whatever it is, and we need to append f. Okay, otherwise it will not be considered as a float value, right? So come here and compile the program and execute the program. See, it got executed, fine. So here we need to modify this particular SOP statements. Okay, so it is float and it is int x, int y, copy and paste it over here. Okay, so int x, int y. So now if you compile the program, and you can see the proper output. So here, yes, so now you can see the corresponding output. So first I have called the 0 argument, so that is the reason why it is printing the 0 argument. Second I called by passing the integer, so this is an integer 1, right? So this is an integer 1, and the third one here I am passing 2 arguments, so it got executed, the 2 argument function got executed, and I am passing finally the float 1, so the float 1 got executed. If you see this output, this message is there in a function which is going to accept float as an argument, right? So here it is the function. So now what I will do is, I will remove this particular int x. The function one which is going to accept integer as an argument, I will remove this. Okay, let me save the program and come here and compile the program. Okay, so I just compile the program, so there is no compilation error. Okay, see here, I am trying to pass integer, but I have removed the function. So though I have removed the function over here, so it is not throwing any compilation error, right? So let me execute the program over here. So it is getting executed fine. That means here, if you observe this, what is the statement it got executed? So this is function 1, so which is going to accept float as an argument, but whenever I try to pass this particular integer value, it is executing the float one. That means what? So in polymorphism there are 3 rules defined. Okay, so the first rule is, so for the first time, at the time of executing the program, the JVM checks for an exact match. Okay, so if you are passing integer, the JVM will search for the function which is going to accept only the integers. Okay, so that is the reason in the first program, whenever we whenever we put the program like this, whenever we see, so I have defined, I reverted this program back. So now it is the function 1 which is going to accept integer as an argument. So now save the program and come here and compile the program. Okay, compile the program and execute the program. So you can see int, right? So the function 1 which is going to accept integer as an argument, it got executed. So whenever the JVM executes this particular state program, so the JVM will first try to identify exact match, I mean to say exact function which is going to accept integer as an argument. It will try to find an exact match of the parameters. This is the first one. If the exact match of the parameters has been found, then obviously it will execute that particular function. That's what we are seeing over here. Since we are passing the integer over here, so here it is an integer, it got executed. So let me revert this program again. Okay, so I will remove that same function. So if you observe this program, I removed the function which is going to accept integer as an argument. Now I will try to compile the program. So here there is no compilation error. Okay, and execute the program. So see here, it is executing the function which is going to accept float as an argument. If you see here, this is the one, right? That means what? The second rule says that if exact match is not found, then obviously the JVM will search for an alternatives. Okay, alternative functions. So an alternative function, what is an alternative function? An alternative function is a function, so for whose parameters we can assign the values, though the values which we are passing at the time of calling the function is not equals to, I mean to say the data type of the values which we are passing at the time of calling the function is not equals to the data type of the parameters of the function. Okay, so if you observe here, the data type of the value which we are passing is integer. Here the data type of the parameter which we are accessing is float, right? So an alternative function is a function which is having the capability to access or to accept the values passed at the time of calling the function, though the values the data type of the values which we are passing is not equals to the data type of the parameters defined inside the function. Okay, that is called an alternative function. So since here this is an alternative function, so the integer value in the sense, so this is a 32-bit value. So 32-bit value can be assigned to the 32-bit memory locations, right? So since float also accepts 32-bit, right? So that is the reason this particular function call executed this particular function. So here this is an alternative function. Okay, so the first rule in the polymorphism says that whenever the JVM tries to execute any program, the JVM try to find an exact match of the parameters. First rule. If exact match is not found, then obviously the JVM will search for an alternative functions. Okay, so since this is an alternative functions, one of the alternative functions, if you mention double over here, so let me modify the program like this. So here I will make it as double. So here it is double x. Okay, so let me save the program and come here and execute the compile the program. So there is no compilation error, and execute the program. See, there is no change in the output. That means there are two alternative functions. This integer value can also be assigned to this double value, but it is considering this one, right? So that means for the highest, if there are multiple alternative functions, then it will consider the priority of these particular functions. That means If this is capable enough, then it will search. If you consider this memory allocation of this one, this is 32-bit and here it is 64-bit. So since there are two memory allocation, two alternative functions are available, so among multiple alternative functions available inside a program, then the JVM gives the highest priority for the lowest one. That means the lowest capable one. Okay, so this is a second rule. So now what I will do is I will create one more class. Okay, class. Otherwise, let me create the same classes in the same program. So here, otherwise come here, divide the classes here itself. Okay, so I have created a class A and I have created class B. Okay, so if you observe this program, so let me save the program with a.java. So let me save the program, and here in this particular Java file there are two classes available. So one is A class and the second one is class B. So now whenever you try to execute this, compile this particular file a.java, okay, so here if you observe this, how many dot class files are there? Here only one dot class file is available. So now I will compile this program. If you see here, there are two dot class files will get created. So one is a dot class and second one is b dot class. Okay, so the next one is, so let me go to this program, and here what I will do is I will create the same function. Okay, so I will create the same function 1, which is going to accept the object of a class as an argument. I will create the same function which is going to accept b class, the object of b class as an argument. Okay, so b class as an argument. Here let us change this a, and here it is b, and here it is b. Okay, save the program and come here and compile the program. Yes, so there will be no compilation error. So now what I will do is, so here I can assign a class. If you want to call the function on which is going to accept object of class A as an argument, then obviously we need to create an object of that particular class and then we need to call that function. So for that one, what I will do is a equals to new a. Okay, so here what I will do is I will call p1 dot function 1. I will call function 1 by passing the object of class A. So I will create object of class B equals to new b. Okay, new b. So then I will call p1 dot function 1 by passing the object of class B. So now if you see this program, so let me save the program and come here and compile the program. So there will be no compilation error, and if you execute the program, okay, java space it is poly 1, yes, poly 1. So let me execute this program. See, the output is this is function. Okay, I think we didn't compile the program poly1.java. Yes, exactly. So java c space poly1.java. See, I just, okay, fine. So it is saying one compilation that the semicolon has been missed. Okay, fine. Let me put the semicolon, save here, and come here and compile the program. See, there will be no compilation error now. So it compiled fine. So if I execute the program, java space poly 1, so here you can see the output function 1 and function b. So that is fine. Okay, so the next one is I will call the function like this, p1 dot function 1. So here null. So if you observe this program, so I am calling function 1 by passing null, right? So what is the default value of a? So assume that the reference has been created as a instance member of this particular poly class. Okay, then obviously the default value of any custom data type is null, right? So here also the default value of b can be null. So I am passing null. Okay, so what will happen is, so now what I will do is I will compile the program. First java c space poly 1 dot java c space poly 1 dot java. Okay, so here see the compilation error, it is saying that ambiguous, right? So here it is saying that ambiguous. That means what? So the third rule of the polymorphism says that if there are multiple functionalities, multiple alternative functions are available in a same level, so then it will throw a compilation error. Okay, that means So here if you consider this one, so this is also these two are all two alternative functions for this particular call, right? So that means here it will consider the priorities of this particular two alternative functions. That means here, though the integer value can be assigned to this x and this x, the data type of these two values are different. That means though there are multiple alternative functions are available, these two multiple functions, I mean these two alternative functions, sorry, not multiple functions, it is alternative functions. Okay, these two alternative functions are in a different levels. Okay, this is 32-bit memory location and this is 64-bit memory location. But if you come here, the null value can be assigned to both the same. That means these two are custom data types. Okay, there is no memory space allocation for this, right? So these two are the custom data type. Okay, so if the JVM finds or Java compiler finds multiple alternative functions and assume that all the multiple alternative functions are there in a single level, then obviously the Java compiler will not allow us to compile the program. Okay, so these are all the three basic rules which we need to follow, while writing the programs using the concept called polymorphism. Okay, so what is polymorphism? A polymorphism, in the sense, it is the concept of defining multiple functionalities with the same name associated with the same object is known as polymorphism. If you come to the point of types of polymorphism, there are two types of polymorphisms are available. So the first one is compile time polymorphism and second one is runtime polymorphism. Compile time polymorphism, in the sense, it is the process of, again, this is the process of defining multiple functionalities with the same name associated with the same object, but out of multiple functionalities defined within the same, with the same name within the same object, so which functionality to be executed, that would be decided at the time of compiling the program itself. That is the reason it is called as compile time polymorphism. So if you come to this point of class polymorphism, at the time of compiling the program itself, it is throwing some error. So at the time of compiling the program, the compiler is checking that at the time of calling this particular function function 1 by passing the value null, so it will search for the functions, so which is the suitable one to execute. So it found two alternative functions, and that too, these two alternative functions are there at a same level. Okay, so now the Java compiler confused that which function to be executed. Okay, that is the reason it is throwing a compilation error. That means among multiple functionalities defined inside the same class with the same name, which function to be executed is decided at the time of compiling the program itself, is known as compile time polymorphism. So here compile time polymorphism can be implemented with the help of classes. Okay, so this is polymorphism and compile time polymorphism. So runtime polymorphism, in the sense, out of multiple functionalities defined within the same class, so which functionality to be executed, that will be decided at the time of running the program depending upon the runtime criteria, is known as runtime polymorphism. So we are going to discuss this runtime polymorphism at the time of explaining the concept called inheritance. So I'm just postponing this concept to inheritance. Okay, so this is about polymorphism. So thank you for watching.